In this video, we're going to learn how to balance these chemical equations using the method of simultaneous equations. Now, I granted this is a pretty hectic list of chemical equations, but this is actually possible. If you know how to work it using the method of simultaneous equations, you're really going to be good here. So we're actually going to take the questions one after the other. So let's start with the first one. I need to scroll this a bit up and gain some space. So the first one is we have X moles of sodium phosphate, and we got Y moles of calcium chloride. And here we have Z moles of sodium chloride, and we got W moles of calcium phosphate. Cool. So what we're going to do is we'll actually start with the first element and find out what is going to be the simultaneous equation that would result as a result of that chemical element. So we're going to start with sodium. Now we got sodium here. Now on the left hand side, what is going to be the value for the atoms of sodium? So we have 3 atoms of sodium here. That will be multiplied by x moles. That gives us 3x. So on the left hand side, as far as sodium is concerned, we just have 3x. Now on the right hand side, we have just a z. So 3x will be equal to z. And that's pretty much it for sodium. Now moving on to phosphorus, we have just 1 atom of the phosphorus from this molecule. But of course, there is actually x moles of the phosphorus. So this is going to be equal to x on the left hand side. And then on the right hand side, we got some stuff here. So here, as you can see, we got just 1 mole of, well, that should be 1 atom rather. So there is 1 atom of phosphorus, and this whole stuff is multiplied by 2. So that would in effect be 2 atoms of phosphorus, and then this is multiplied by W moles. So that will be 2 multiplied by W. So that will be equal to 2W. That will be the equation created as a result of phosphorus. Now let us go on to oxygen. Now on the left hand side, we have 4 atoms of oxygen, and there is x number of moles. So that will be 4 multiplied by x, and that's 4x. Now on this side, we have 4 multiplied by 2, and that will be multiplied by w. So that should be 8w. And then we're moving on to calcium. So calcium, we just got y number of atoms for it on the left hand side. So that will be equal to y. Then on this side, we just got z. So that's going to be equal to z. And that's okay. So we just need to add up chlorine. So chlorine on the left hand side, we have 2 atoms of it, and that will be multiplied with y. So that gives us 2y. Then on this side, we're going to have z number of moles, because here we got just 1, and that will be multiplied by z. So that will give us a z. So these are the equations would form as a result of the chemical equations, or chemical elements rather, that we have. So this is what you need to do. You need to fix one of the variables or the letters as 1. Now most times I'm actually keen to setting x to be equal to 1. So if I actually set x to be equal to 1, I'm going to use that value to find out what will be the value for the other letters. So let us start with this equation. So if you have x to be equal to 1, that will be 3 multiplied by 1, and this will be equal to z. So that means z is equal to 3. So I'll just write that here. So right now we got x and z. Now we also know that x is equal to 2w. So we know x that's equal to 1, and this will be equal to 2w. So w will be equal to 1/2. So let's write that here. So this is 1/2. So right now we've gotten the answer to at least 3 letters. Now we need y. So here now we can see that 2y is equal to a z. Now over here we have y is equal to a z. Okay, so I need to make sure this works or is correct. Calcium, right? So there is actually a mistake I need to correct here. For calcium, on this side we have y number of atoms of calcium, but on the right hand side we got 3 atoms. So this is 3 and that will be multiplied by w. So that will be equal to 3w. This is what's supposed to be here. This is the correct one. Now we need to find y. Let's use this equation. Y is equal to 3w. So this will be y, and that will be 3 multiplied by 1/2. So that gives us 3/2. So y that is equal to 3/2. So right now we found all those. Just need to plug in those values into the equation and see what that is going to give. So for x, we have 1. So I'm really not going to write anything there. That would just be Na3PO4. And for y, we have 3 divided by 2. So that will be 3 over 2. Calcium chloride. And then we have Z. Z that is equal to 3. So that will be 3 moles of sodium chloride. Next up we have W. W is equal to half. So that will be 1 over 2. Or added to or multiplied by calcium phosphate. So this is what you're going to have. Now you need to understand something. When you solve questions where you need to balance chemical equations, you're not actually permitted to have denominators as, or let's say fractions rather. You cannot have fractions as coefficients or number of moles of various compounds or molecules. So how can we solve this problem? So what you need to do, you need to take the denominators of the fractions and find the LCM for them. And unfortunately happens to be that we got 2, just 2's here. So the LCM of 2 is 2. So you're going to take that LCM and multiply through the whole equation with it. So let's do that. First off, I'm going to multiply sodium phosphate with 2, and that will be 2 moles. So this is what we have. Here I'm going to have 2 multiplied by 3/2, and that would cancel the 2 away. So that leaves me with 3 moles of calcium chloride. Now on this side we are going to have 3 multiplied by 2, so that will be a 6. So this is sodium chloride. And here we're just going to have a 1 because 1/2 multiplied by 2 will give you a 1. So that will be calcium phosphate. So this is actually going to be the answer to the question. Now let us go on to the next one. So here is the second one. So as usual, well, I'm just going to try to take this out. We know that x will be the first variable. Let's say y is here. Let's place a z here. So we're just going to have a z there. Let's say we got a w here. So as usual, I'm going to create those equations as a result of the chemical elements you got on both sides of the equation. Now let's start with nitrogen. So for nitrogen, we got 3 atoms of nitrogen. That is because you have the 3. that is outside the bracket, so you gotta multiply that with the nitrogen within. And that will be multiplied by x, so that's equal to 3x. And here now we also have another nitrogen atom, but right now we have 4 as a subscript for the bracket. So that will be 4 multiplied by 1, that gives us a 4, and that will be multiplied by y. So that should give us a 4y. Now on this side, we don't got no nitrogens for the first molecule, but there is a nitrogen here. Now there is W number of moles of the whole molecule, ammonium nitrate. There's just one atom of nitrogen, so that will be multiplied by W. This will be the equation for nitrogen. Now let's go on to hydrogen. So for hydrogen, we got 4 atoms within the bracket, and that will be multiplied by 3. So that gives us 12, and that will be 12 multiplied by x. So that's going to give us up 12x. Now we don't got no nitrogens from the second molecule. We don't have no nitrogen here. We got 4 atoms of nitrogen for the last molecule, and that will be multiplied by the number of moles, which is W in this case. So that will be equal to 4W. Now let us go on to phosphorus. Now for phosphorus, from here, as you can see, we just have 1 atom of it. So that will be multiplied by x, and that's basically just going to give us an x. Now on this side, we have 4 atoms of the phosphorus. We know there is just the one within the bracket, but that will be multiplied by x. Well, by 4 rather. That should be 4. 4 would be multiplied by z. So that should give us 4z. And next up, we got oxygen. So oxygen, we got 4 atoms of oxygen for the first molecule, and that will be multiplied by x, so that's going to be 4x. Now we got another oxygen atom, or numbers of atoms of it, for the second molecule. So this is going to be 3 multiplied by 4. That gives us a 12. So that will be 12 multiplied by y, and that will be 12y. Now on this side, we're going to have so this is 4 atoms of the oxygen, but we got 4 as a subscript outside the bracket. So that will be 4 multiplied by 4, and that will give us 16. So that will be 16 multiplied by z. That gives us 16z. And then here we have 3 atoms of the oxygen. That will be multiplied by W. So that will be 3W. So I think the last one now is lead. So for lead, on the left hand side, we just have a Y. And then on the right hand side, we have 3 atoms of lead. That will be multiplied by Z. That's basically it. So that will be 3Z. So these are the 5 equations you're going to form. Now, as usual, you're going to set the first letter to be equal to 1. You're going to use that to find out what will be the value for the other variable. So I'm going to start with x. So let x be equal to 1. Now plug x into this expression as well as this. That would help me to find w and z. So here we have 12, and that will basically be multiplied by 1. So this will be equal to 4. So this is 4w. I think I don't really need to write the bracket. So 12 is equal to 4w. And so w will be equal to 3. So we need to write that there. Now let's also use x as 1 for equation p. So that will be 1 is equal to 4z. And so, of course, you know this is going to be z is equal to 1 divided by 4. So right there we have z. Now we're going to use these 3 values to find out what y is from the first equation. So this is going to be 3 multiplied by 1 plus 4y. And this will be equal to w. So that's what you have. Now from here, okay, so this will be 3 plus 4y, and this is equal to 3. So this should be equal to 0, and therefore y should be equal to 0, which is not really correct. So I think I need to check that equation once again. Let's see if we're actually correct with that. So that is due to nitrogen. So this molecule is correct. We got 3 atoms of it. That will be 3 multiplied by x. This is correct. Now here, okay. So yeah, this is correct as well. Nitrogen here will be 4. So that will be 4 multiplied by y. So the left hand side is correct. And the right hand side is correct as well. So that doesn't help us. Well, let us use the last equation. Let's use this one. Y is equal to 3z. So this will be 1/4. So y should be equal to 3/4. We're actually going to come back to this later on to find out whether or not there was an error. But there is no error here. I cannot see any error there. But let's just go on, by the way. So this is basically it, right? Yeah. So we're going to plug these into the equation and find out whether or not we're going to have the answer. Okay. Let me try using this equation with the values of x, y, and z. So this will be 4 multiplied by 1 plus 12y. And on this side, we're going to have 16z. Z, that is 1/4 plus 3w. So that will be 3 multiplied by 3. So here we're going to have 4 plus 12y. And this is going to cancel to give us a 4. So that should be 4 plus 9. Now we know these ones are just going to cancel. So we're going to have 12y to be equal to 9. And so y, that should be equal to 9 divided by 12, which is the same thing as 3/4. So we're actually correct with that. But I don't really know the reason this other equation seems to give us a problem. Right now, we don't really got time to go back to that. So let's just go on. Now just replace all these variables with the numbers. So for x, we got 1. So you don't really need to write anything there. And then for y, we have 3/4. That will be lead nitrate. And then you got z. Z, that is equal to 1/4. So that is 1/4 lead phosphate. And we got W, which is equal to 3. So that will be equal to 3. To write that up. This will be ammonium nitrate. So we gotta have a 3 there. So let's find out whether or not this is correct. So for nitrogen right now, we got 3 nitrogens here. And here we have, well, of course, we should not really go there yet. We need to take the 4 and multiply through the whole equation with it. That is for the sake of the non-allowance of fractions as numbers of moles of various compounds in a chemical equation. So I just got to take 4 because these are the denominators. We just basically have 4. So that will be 4 multiplied by this stuff. That will give us 4. So this should be NH3. Well, NH4 rather. Of 3, PO4. And here we're just going to have a 3 lead. And here we're just going to have a 1. So that will be Pb3, PO4. And here we're going to have 4 multiplied by 3. That's going to give us a 12. So that is going to be the answer to the question. This will be the balanced equation. Now let us go on to another one. That is the second one, right? Now here is the third one. Well, that should be the third, not the second. So we got X here, and that is sodium heptaoxo tetraboronate, whatever. If you just want to find the oxidation state, you can go ahead. But this will be B4O7. Feel free to find out what is the name for this compound. And this will be Y. So we got Y moles of sulfuric acid. And we're going to have a Z number of moles of water. This is Z moles of water. And this will be equal to, so let's say W. I'm going to use this color. W moles of sodium sulfate. Yeah, that's correct. Plus, so here now we're going to have a, let's say that's a V. Okay, so I'm going to use a blue. So that is V moles of HBO3. So this is the equation. We need to balance it. So for sodium, on this side, we're going to have 2. So that will be 2 multiplied by x. That gives us 2x. So that's pretty much it for sodium on the left-hand side. Now on the right-hand side, we still have 2 moles, or 2 atoms rather, for sodium. That gives us 2 multiplied by W, which will basically be equal to 2W. Now for boron, we have 4 atoms of boron. That will be 4 multiplied by X. So that's a 4X. Now on this side, we just have 1 atom of boron, but that will be multiplied by V. So 4X will be equal to V. Now next up, we have oxygen. So for the first molecule, you have 7 atoms of oxygen. Multiplied by X, that gives you 7X. And then for the second molecule, you have 4 atoms of oxygen multiplied by Y. That gives you 4Y. And then you have 1 atom there multiplied by Z, so that will be a Z. And this will be equal to 4W and plus 3V. This should be about the longest equation in this whole set of equations. Now how about hydrogen? So we're going to have 2Y plus 2Z. And this will be equal to 3V. Now next up, we have sulfur. So sulfur basically just has a Y on the left, and on the right, we're just going to have a W. Now as usual, we know that from this point, you can actually set X to be equal to 1. And if I set X to be equal to 1, I could actually use this first equation to find W. So that means W will still be equal to 1. And then V, that will be equal to, so we know this is going to be X, and that will be 1. 1 multiplied by 4, that gives us 4. So in that case, V is equal to 4. Now what will be Y? So Y, that's going to be equal to 1. I'm going to have this as a 1. And then Z, so we could use this equation to find Z. As much as possible, try to use the equations that look less complex. So that will be 2 multiplied by 1. And then this is plus of 2Z. This will be equal to 3 multiplied by V, which is 4. And so this will be 2 plus 2Z is equal to 12. And so we know that you can take 2 away from here, and that will give you 2Z is equal to 10, right? So Z should be equal to 5. So let's plug these ones into the equation. So X is 1, so we don't need to write anything there. So this will just be Na2B4O7 plus Y. Y is equal to 1. So I just have H2SO4 plus Z, that is 4, water. Z, that is equal to 5. This will be equal to W, sodium sulfate. W is 1. And you have V. Now V is 4. So this will be H3BO4. Well, BO3 rather. So this is actually the answer to it. This will be the balanced form. Feel free to check it out. Try to find out what will be the number of atoms for each element on both sides. For instance, here you have sodium. There is 2 sodiums here and there is 2 here, right? We have 4 boron here and there is also 4 boron here, as you can see. So go ahead and complete that. If you do that, you find out that the number of atoms of each element on the left hand side, that will be equal to the number of elements on the right hand side. Now that is the only criterion that you'd use to find out whether or not the chemical equation is balanced. Now let's try the fourth one. So the fourth one, that is X moles of copper added to Y moles of the nitric acid. This is equal to, let's say, you got Z moles of the copper nitrate. Okay. Well, let's say we have W moles of NO. Let's say we have Z moles of water. So that's what you have. Now here, copper, that will be X on the left hand side, and on the right hand side we're going to have a Z typically. Then hydrogen, so that is a Y on the left, and on the right we're going to have a 2Z. Then we got nitrogen. Nitrogen on the left will be Y, and on the right we're going to have so first we know that the subscript for that bracket is 2, so that will be 2 multiplied by Z, so that should be 2Z. And here you're going to have a W, so that will be plus W. And the last one is oxygen. So there is 3 atoms of oxygen on the, let's say on the atom side of the right or the left hand side. And so that will be multiplied by Y, so that gives us 3Y. And then on the right hand side we have 6 here, that will be 6Z plus W plus Z. Whoa. So I needed to change this. This was a mistake. Whoa. Let's say this is a V. That is a gross mistake. So for hydrogen, this should be a 2V. And then for oxygen, this should be a V. So that's what you have. So if X is equal to 1, then Z, that would also be equal to 1. So let's see. Now let's plug in these stuff into the equation. So if we have Z to be equal to 1 from equation N, you're going to have Y is equal to 2Z, which is going to be 1. So that will be 2 multiplied by 1. So this is going to be Y is equal to 2 plus W. Then let's move on to this one. So for this one, we're going to have our 3Y. That is equal to 6Z, which is 1 plus W plus V, right? And so this should be 3y is equal to 6 plus w plus a v. Okay. Now for the first or the third one, we have y. Y is equal to 2v. So these are actually the three equations you would need. You have y is equal to 2 plus w, and then here you have 3y is equal to 6 plus w plus v. Now remember, in order to find out the value for three variables, you need three equations, right? You just need to build a simultaneous equation to do that. So I'll just do that right away. So let's just rearrange it. So for the first equation, we have y minus w is equal to 2. That is for this one, right? Then for the second, let's say you have 3y minus w minus v is equal to 6. And the third one is y minus 2v. That's equal to 0. So let's solve it. So we have the coefficient for y is 1 for the first equation. Now what I'm actually doing is I'm using my calculator to do this because it's some pretty long. I don't really want to waste the time. So I believe you have your calculator to do that yourself. Now the coefficient for w is -1. And we don't got no v there, so that will be 0 for v. Now on the equation side, we got 2. And for the second, we got 3. And that will be -1 for w and -1 for v. That's equal to a 6. Now for the last equation, we got 1. That's negative. What we got is 0 for w, because there's no w for equation 3. Then for v, we have -2. And on the other side, we just got a 0. So let's start with the first values we have. So that is y. Y, that is equal to 8 divided by 3. And we have w, that is 2 divided by 3. And then v, that is equal to 4 divided by 3. So we're going to take these values and plug them into the equation to have x is equal to 1, y is equal to 8 divided by 3, z that is equal to 1, w that will be 2/3, and then v, let us write it here, v is equal to 4/3. So the equation should be, okay, so I think I'm just gonna wipe these ones out. I'll use this place. So for x, we said that should be a 1, so that's not really going to change anything. Now y is equal to 8/3. So this is 8 divided by 3. And for z, we got 1. So that will be a copper nitrate. W is equal to 2/3. So that will be NO. And then V is equal to 4/3. So that will be 4/3 of H2O. So as usual, we're going to cross or we're going to multiply through by 3. So this would give us 3 copper. Here we're going to have 8 nitric acid. And here we're going to have 3 copper nitrate. Here you're going to have 2 NO. And here we're going to have 4 water. So this will be the balanced form of the equation. That's how to work it. Now let us move on to the last one. Now for the last one, you got calcium fluoride plus Y moles of sulfuric acid, and we got Z moles. That will be Z moles of silicon oxide, and this will be equal to W moles. W moles of calcium sulfate, and we have V, so that will be plus V moles of silicon fluoride. So you got this, and then the last one is so let's say this is a P moles of water. So for calcium, we have X here. That will be equal to W. For fluorine, we have 2X. And on the other side, we have 4. So that will be 4 multiplied by V. So that's a 4V. And for hydrogen, we got 2Y. And then on the other side, we got 2P. And for sulfur, right? Sulfur, we got Y, just a Y. And then on the other side, we got W. Then for oxygen, so there is a 4Y plus 2Z. This will be equal to 4W plus OP. And then the last one is going to be silicon. So for silicon, we have a Z on the left, and on the right, we have a V. So I'm going to set X to be equal to 1. Therefore, W will be equal to 1. And we have 2X is equal to 4V. So that will be 2 multiplied by 1 is equal to 4V. So 2 will be equal to 4V. And so V, that should be equal to 1/2. Okay. Now again, V is equal to Z from equation SI. So that means Z will be equal to 1/2. Now here you can see Y is equal to W. So Y also will be equal to 1. Therefore, if you have 2Y is equal to 2P, that means P would also be equal to 1, because that will be 2 is equal to 2. Now we're going to plug these ones into the equation. So X, that is a 1, so that's a basic calcium fluoride, plus Y is a 1, so that's a H2SO4. Z, that is a 1/2, so that is 1/2. And here we're going to have W, that is a 1, so that will be calcium sulfate. And V is equal to 1/2. And we got water, P is equal to 1, so that will be water. Now in order to balance this, we need to multiply through by 2, which is the denominator for 1/2. So this is going to be 2 CaF2 plus 2 H2SO4 rather. Here we're just going to have a silicon dioxide. Here we're going to have 2 calcium sulfate. Here we're going to have silicon fluoride. And here we're going to have 2 moles of water. So this is going to be the answer to the question, this one. So right now you can see that you can easily balance out any chemical equation by the method of simultaneous equations. Now, I actually believe this is the easiest or most straightforward way for finding the answer to unbalanced chemical equations, because sometimes if you use the random method, the trial and error method, sometimes you may really just go around cycles and really not come to the answer, and that pretty much is going to waste your time. So I believe this method is the most important or the most useful or effective as far as time management is concerned. Now, if you're interested in more videos like this, feel free to subscribe to the YouTube channel, and there are other links to the Telegram or channel I have where I catalog these videos in their database order, something like that. They're gonna have more videos like this for 100 level, first level, first year chemistry, second year chemistry, and so on and so forth. So if you're really interested in that, feel free to check out the links that have been dropped on the description section below. See you in another one.